Good morning, friends. Today we are going to cover another important topic, that is electrochemical machining. Electrochemical machining is one of the newest and most useful non-traditional machining process, which belongs to the electrochemical category. Electrochemical machining is used to remove metal and alloys uh, from the uh, to remove metal and alloys which are difficult or impossible to machine by mechanical machining process. So this process is a reverse of electroplating. Okay, so electrolysis has been successfully put to work in the areas like electroplating, electroforming, and electrofluorescence. So the process of metal removal by electrodissolution was known a long back, but only over the last couple of decades that this method has been used to advantage, and this is also known as contactless electrochemical forming process. This process is works on the principle of Faraday's law of electrolysis. Faraday's law of electrolysis gives two statements. Okay, so the weight of substance produced during the electrolysis process is directly proportional to current which passes, and then length of time of process and the equivalent weight of material. Two dissimilar metals are in contact with electrolyte, and anode loses metal to the cathode. So this is a basic principle behind this process. Now this process is used for the different parts. Here I have shown some examples. So you can go for the manufacture of turbine blade made up of the nickel alloys and shape of the electrode on the right. So this again thin slot on a 4340 steel roller bearing case. Now we will move for the basic principle of the this electrochemical machining. That is a working principle. In electrochemical machining, a small electric DC potential, that is 5 to 25 volt, is applied across the two electrodes, that is cathode and anode. Anode is work and cathode is tool, which you have to immerse in the electrolyte as shown in the figure. During electrochemical machining, there will be a reaction occurring at electrodes, that is at anode or workpiece, and at cathode or the tool along with within the electrode. Let us take an example of machining of the low carbon, which is primarily a ferrous alloy mainly contain iron. For electrochemical machining of steel, generally a neutral salt solution of sodium chloride is taken as the electrolyte. The electrolyte and water undergoes ionic dissolution as shown in the formula, that is NaCl will give the Na plus and Cl minus. H2 also gives H plus and OH minus. As the potential difference is applied between the workpiece and the tool, the positive ion move towards the tool and the negative ions move towards the workpiece. Thus, the hydrogen ion will take away electron from the cathode, that is tool, and from the hydrogen gas will get the H2 at cathode. Similarly, the ion atoms will come out of the anode and will get the Fe plus 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 2 electron. Within the electrolyte, iron ions would combine with the chloride ions to form iron chloride, and similarly sodium ions would combine with the hydroxyl ions to form a sodium hydroxide, that is NOH. So in practice, FeCl3 and FeO2 would form and get precipitated in the form of sludge. In this manner, it can be noted that the workpiece gets gradually machined and get precipitated as a sludge. Moreover, there is a not coating on the tool. Only hydrogen gas evolved as the tool or cathode. So this is the basic principle behind this process. So here also I have shown the how metal is removed from the workpiece with the help of the electrolysis procedure. So you have to mention the workpiece as anode, and tool will act as cathode, and electrical conductive fluid also use, that is electrolyte. Now let us highlight some of the process parameters. So first is the power supply. So you have to use the DC power supply having the 2 to 35 volt voltage, 50 to 40,000 ampere current, zero point 0.1 ampere per mm square current density. Then second is the electrolyte. So material or fuel for the electrolyte, you can use NaCl and NaNO3, and you have to maintain the temperature 20 degree to 50 degrees Celsius. Then pressure 0.5 to 20 bar. Okay. Then working gap 0.1 mm to 2 mm, you have to keep working gap, and you have to maintain the work at 0.2 mm to 3 mm, and you have to give the feed rate 0.5 mm per minute to 15 mm per minute. And electrode material, you can keep copper or brass or bronze, and surface roughness you will get 0.2 to 1.5 micron. So just I have explained the how this process, that is the electrochemical process, works. So there are the different elements or the components is required, and the important elements of electrochemical machining are the DC power supply, then electrolyte supply and cleaning system, the tool, that is cathode and tool feed system, workpiece and work holding system. So here I have shown the regarding power supply. So available in sizes up to 10,000 ampere. Some circuit are available up to 400 ampere. So you have to keep this range of voltage also, and you have to give the constant voltage for as to be maintained for the machining, and high density is required. Then electrolyte. So it is essential for this electrolyte process, and it cools the cutting zone, which becomes hot due to the flow of the high current. Neutral salt are also used for the as a electrolyte in place of the highly corrosive acids and alkaline. Electrolyte solution is pumped between the tool or workpiece gap at about 2.5 Newton per mm square and 30 meter per second. The requirement of the tool for electrochemical machining is good thermal conductivity, strong enough to withstand high pressure. It should be easily machinable. So material for the tool you can take as copper, brass and SS also. And outer insulation material you can keep vinyl, Teflon, epoxy, which enable or high temperature varnish. Therefore, control system, there are the control parameters which include the voltage, inlet and outlet pressure of the electrolyte, temperature of electrolyte. The current is dependent on the above parameter, and feed rate. So here I have shown the. Let us discuss about the advantages. So electrochemical machining is well suited for the machining of complex two-dimensional shape. So you can use for the duplication of part. Then you can machine the difficult to machine geometries. Also ECG is useful for processing of poorly machinable material, and little or no tool wear in during this process. Disadvantages. So initial tooling can be timely and costly, environmentally harmed by products, and complicated tool design. So these are the some disadvantages. Also it consumes large power. Now let us highlight some characteristics about the ECA. Stress-free grooves, any groove geometry, any conductive metal can be machined, repeatable accuracy is high, high surface finish you will get, fast cycle time is there, and this process is economical when a large number of complex identical products are to be made, and large cavity are more economical on electrochemical machining and can be made in 1/10 time in the ED, uh, EDM. So this is these are the characteristic. uh, so this electrochemical machining also you can use for the most common application, that is a duplication. Okay, then also for thin wall or easily deformable and brittle material. Also it is used for machining of hard heat resisting alloys. Also it is used in the cutting cavities and holes in various products. Machining of the complex external shapes like that of the turbine blade, aerospace component, and machining of the tungsten carbide and nozzle of alloy steel. And any conductive material can be machined by this method. This is an important application of this electrochemical machining. Okay. So this is about the today's session. Thank you.